Big question today, how do blockchains talk to the real world? The answer is simple but powerful. They use something called oracles without oracles. Blockchains are blind. They can't see prices, weather, or events. Blockchains only know what's inside them, and that's a big limitation because real-world data matters. That's where oracles step in. Oracles act like bridges. They bring external data into blockchains. Prices of assets, stock values, sports scores, even weather conditions and election results. This data powers smart contracts. And smart contracts automate agreements, for example. Insurance can use weather data. A smart contract pays farmers automatically if rainfall is below a certain level. No middleman. No delay. Let's take another example. Decentralized finance needs price feeds. Traders need to know ETH price in real-time. Oracles deliver that price. Smart contracts then execute trades correctly without oracles. DeFi would collapse because blockchains alone can't fetch prices. They need trusted data inputs. Oracles supply that trust, but how do they really work? Oracles collect data from outside sources. This could be websites, APIs, or sensors. Then they transmit it to the blockchain. A smart contract receives the data and takes action automatically. The process sounds simple, but it's actually very complex because the data must be accurate. One bad input can break everything. That's the oracle problem. The oracle problem is trust. If one oracle gives wrong data, the whole system can be exploited. Hackers could manipulate prices and drain millions from DeFi platforms. That's why security is critical to solve this. Decentralized oracles exist instead of one source. Multiple sources provide data. They're verified by a network. The best-known example is Chainlink. It uses decentralized nodes to confirm data. Nodes fetch information independently. They compare results. Only the verified outcome reaches the blockchain. This prevents manipulation and makes the system reliable. Other oracle projects exist to ban protocol. API 3, DA each, with its own model. Oracles can be inbound or outbound. Inbound sends data into blockchain. Outbound sends data out of blockchain. Imagine a smart lock. It opens when a payment on blockchain confirms. That's an outbound oracle in action. It sends blockchain data to the real world. Connecting digital and physical systems, this opens huge possibilities. From supply chains to IoT in supply chains, sensors track goods. Oracles send that sensor data to blockchain businesses, then verify shipments instantly. Payments can be triggered automatically. Removing fraud and delays in gaming, oracles bring randomness. They ensure fair results in blockchain games. In betting, oracles confirm real-world scores and release payouts without disputes. The use cases are endless, but challenges remain. Speed, accuracy, and trust must improve. Decentralized oracles are the answer, but they're still evolving. More nodes mean more security, but also higher costs. Balancing efficiency and safety is key. Oracles must be fast and reliable because blockchains run on precision, and even small errors can be disastrous. Oracles are the unsung heroes of blockchain. They connect code with reality. They enable DeFi, insurance, gaming, and supply chains. Without them, smart contracts stay limited. With them, the possibilities explode. The future of oracles is bright as blockchains scale. Oracles will scale till they will power the next generation of applications and make blockchain truly connected to the real world.